Assalamualaikum and hi. In this video, we're going to go through the solution for question 3, week 10 Java methods. Before we move on to discuss about these questions, I'm going to make minor corrections for question 2, where previously I've shown you that when you're doing the print line here, you have the plus operator here. But the actual answer is that you need to remove these plus because it does not make sense to be there, right? So that's just a very minor typo there. Now let's move on to question 3, where for question 3, you are asked to create a Java programs that display prime numbers. So we know that prime numbers in Malaysia we call it as nombor perdana. And it says that this program must include a method name is prime, which takes an integer as an argument and return true if the argument is a prime number or false otherwise. As little definitions related to prime number, it say prime number is a number that's only divisible by itself and one without a remainder. So we need to check on that. And for example, 5 is a prime number because it can be divided evenly only by 1 and 5. However, 6 is not a prime number because it can be divided evenly by 1, 2, 3, and 6. So here there are a few things that we need to consider or before we move on to write our Java codes. So other than 5 and 6, there are a few numbers that we know that, which are not prime number. For example, we know that 0 and 1, these are not prime number. Okay. So we will need to add the conditions for that. Whereas for other numbers like 5 and 6, we will need to do some checking. For example, for 5, we will need to divide 5 with 2, 3, and also 4, okay? Because we know that 5 divided by 5 is always equal to 1. And whereas for 6, we will need to divide with 2, 3, 4, and also 5. Again, 6 divided by 6 is always equal to 1. Now, 5 divided by 2, we know that there is a remainder, okay? Similarly to 3 and also 4. Whereas for 6 here, for example, 6 divided by 2, we get a whole number here, which is 3, right? So just by looking into this, then we can make decisions or conclusions saying that 6 is not a prime number. So again, we will need to write Java codes to show that or to check that whether a number can be divided by itself and 1 without a remainder. So here we're going to use if statements, okay, for the values 0 and 1, whereas for any numbers which is equal or greater than 2, we'll need to do a checking here. And if you look into this checking will involve looping. So now let's move on to write some Java codes. So I'm going to add a code cell here and just assume that I have a number integer my num is equal to 0. So I can just say if my num is equal to 0 or my num is equal to 1, then I can do, for example, system.out.println. This is not a prime number. So I'm done with the first conditions. Now let's look into the second conditions where I'll need to do a looping. So assume that my number is 5. So I'll start by doing for integer I equal to 0. There's no point to check with 0 and 1 in this case. And I less than the given number, which is my num, okay, and I plus plus. So what I'm going to do here is I'm going to do a system.out.println, and I'm going to do my num modulus 2. Sorry, modulus I, okay, because I want to divide with all the possible value here. I can run this. So what you have here, my num is equal to 5, right? Okay, so when I go into the loop, my first loop is I do 5 modulus 2, okay? And then of course the second is 5 modulus 3 because I have this I plus plus here. and 5 modulus 4. So of course, when I is equal to 5, then 5 is less than 5, which is false. Then I straight away go out from the loop. Okay, you see 1, 2, 1 here is because 5 modulus 2, the remainder, okay, the remainder is 1. 5 divided by 3, the remainder is 2. 5 divided by 4, the remainder is 1. So this is what you have here. So for a given number, if we divide that with all the possible value of I, and all of the outputs are the one with remainder, then we can claim that the number is actually a prime number. I'm going to show you another example here, where I'm going to change this 5 to 6. Now, if I run this, you will see 0, 0, 2, 1. In the loop here, we do 6 modulus 2, 6 modulus 3, 6 modulus 4, 6 modulus 5. Okay, so 6 divided by 2, there's no remainder. Again, this is the remainder, as you can see here. So this is 0, this is 0 as well, because we get 3, we get 2. Here, of course, the remainder is 2, the remainder is 1. But it doesn't matter how many numbers that you divide contains no remainder. As long as there's 1, for example, in this case, I can actually make a conclusion saying that that number is not a prime number. So now to extend this further, what I'm going to do is I'm going to add a if statements where I say if my num modulus 1, okay, is equal to 0, then I will say system.out.println this is not a prime number. Okay, I'm going to run this, and you will see that there are 2 times here display this is not a prime number, this is not a prime number. Well, what you can actually do is, because we just want to hit one conditions and then we can make a conclusion, so you can just put a break keywords here. Okay, so once you hit a conditions that finding out that the numbers divided by, for example, here 6 equal to 0, the remainder is 0, then you can straight away make a conclusion saying that this is not a prime number. So what we can do now is we can combine both of these and put these into a method. Now, if we go back to the questions here, it says we need to create a method is prime. There's an argument, it will return, so we know that it's a return type. And because the return is either true or false, so of course I will need to have Boolean there. So I'm going to add another code cell. I'm going to start with writing Boolean is prime, is the name. And here I will need to have a parameters integer my num. Okay. Well, you can just put num, and then I'm going to open and close it. What I'm going to do is I'm going to copy this. I do not need the initializations because now it's based on the arguments that I feed into this parameter. So this is my first conditions, and this is my second conditions here. So because it is a return type methods, and we know that it's going to return a value which is either true or false, booleans. And what we're going to do is we are going to add something inside our conditions here. So it says that if my number is equal to 0 or my number is equal to 1, that it is not a prime number. So I'm going to return false here. Because if you look back into the requirements here, it says that if the number is prime number, I return true. If not, then I return false. So here, of course, when we meet the conditions here, I'm going to print this not a prime number, so I return false. I'm just going to comment this out. And similarly for this one, I'm just comment out the print line, and within this, I can remove the break as well. So here I'm going to add in another return false. Okay, so that when the conditions match, then straight away I will return false without the need to check on other values. And if a given number does not meet these conditions and does not meet these conditions, then outside of these two conditions, I'm going to return true. Okay. Now let's try to run this by giving an argument. So is prime, I will just call the method here, and let's say it is 6. Now I'm going to assign that to variables. So for example, well, I do not need to do that. Okay, so I can, to check on the value, I can simply do system.out.println, okay, whether it's prime. Now if I run that, so is prime 6 false? Is not a prime number. 5, and there's something wrong here. If I look back into my method here, well, the problems lies here because here, instead of using my num, I should change all these to num, right? Because remember, my parameter here is num, okay? So I need to change all this to num. But that's one of the issues with Google Colabs, where even though I didn't declare the value of my num here, it will assume that the value of my num is coming from here. That's why you can still see false here. Okay, so I'm going to run this again. And well, there's one more here, which is num. And I'm going to run this, and you're supposed to get true. Okay, so it seems like our methods works. Let's say 1. We try maybe another numbers. 10, we know that 10 is not a prime number, so false. And if it's 7, then it is true because 7 is a prime number. So once you are done with this, then we can actually move on to the next step. We already have is prime methods where it can take an integers and return true or false given the number is either prime or not prime. Now here we will need to display the prime numbers between 1 and 55. So what we can do here is, first, without calling the methods, what we can do is we can write a looping to print all the numbers between 1 and 55. So here we can do for integer j is equal to 1, j less than or equal 55, j plus plus, okay? As usual, let's try to do something step by steps, okay? We do the looping first, print all the numbers, then only we call the methods and to further decide whether these are prime or not prime. So system.out.println j, if I run this, I should be able to get or see all the numbers from 1 to 55. So yes, 1 to 55. Now, I want to only print the prime number, so I can just call the method if, okay, is prime, okay, and put in j here, then only I will print it, right? Okay, so I'm just going to copy this one and paste it here. Now, if you look into this, basically what this does is, this is the method here. I put in the j, which is the numbers that is going to increase from 1 to 55. So I'm going to check whether it's prime or not. We know that from previous sections here, it will only return true if the given number is prime. So here, if j is a prime number, then this will become true. Then only I will print it. So basically is if true, then I will print the number. So let's run this, and you will see all the prime numbers here. So we have from 2, 3, 5 up until 53. Well, there's actually an extra note related to how you can optimize the code. You can explore this yourself. I don't want to confuse you with much more complex situations. But what it says here is basically you do not need to check up until num here, which, for example, if let's say an input is 110, you do not need to check up until 110. You can check up until 110 divided by 2, which is kind of like half. Okay, so this is one of the way that you can do optimizations of your code. But I think as a start, it's good that I show you the most basic coding here so that you can truly understand what is this method about. Thank you very much.